Hello, so question number 137 says that a metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degrees with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction 0.25 T is acting on it in the vertical direction. The current flowing in the rod is to keep it stationary is. So like always we will underline few things. We have like mass per unit length which is 0.5, and then we have angle which is 30 degrees with the horizontal, and then we have magnetic field of induction which is 0.25, and then lastly we have to find the current flowing. And the correct answer according to the question is second option, 11.32. Now let us see how. So we consider the inclined plane like this, and which makes theta with the horizontal. Now suppose the metallic rod is somewhere here, so in this direction we will have ILB cos theta, ILB cos theta, and in this direction we will have mg sin theta, and this is our normal. So ILB cos theta is equals to mg sin theta, and from here we can find I equals to m by L bracket g tan theta by B. So we know what is m by L, 0.5. We know what is G, 9.8. We know what is tan theta, tan 30, 1 by root 3, and we know what is B, that is 0.25. Now if you put all the values in this equation, the answer will come out to be 11.32 ampere. Thank you.